Hello, everyone, and welcome to Session 2 of HP's Beyond the Forge, a metals 3D printing series. My name is Zach with HP 3D Print Metals Marketing, and I'll be your host. If you're new to Beyond the Forge, this series will consist of 12 30-minute bite-sized webinars providing the main information you need to understand 3D printing with the HP MetalJet solution. Each session will showcase a different important topic along with giving the attendees the ability to vote for next session's topic. So make sure to stay until the end to cast your vote. From last session, our topic this month is benefits of 3D printing versus traditional methods with Brett Harris, Senior Global Product Manager for Metals. Now, before we jump in, keep in mind we have the Q&A options available at the bottom, so be sure to submit your questions and we'll try to answer them during the presentation, or we'll follow up with you via email afterwards, so keep your questions handy. Now, I'll hand it over to Brett to explain where and when 3D printing with MetalJet is more beneficial. Go ahead, Brett.
Zach, thank you. Appreciate it. And good morning, good afternoon, everyone. It's great to be here to have a conversation with everyone and kind of give everybody an insight into our experiences with 3D printing, HP MetalJet, and how it competes and complements traditional methods of manufacturing. So we'll get into the agenda. Click on the right button here. So today's agenda is kind of outlined here. What I'll focus on is, I want you to, as we go through the content today, is really try to emphasize that you focus on three key elements of the messaging here. One is that manufacturing is constantly evolving. It is not a static process. There's always been improvements and innovation within manufacturing, so it's constantly evolving. The other is, in manufacturing, is one of the things that we tend to focus on here at HP is really identifying and solving customer pain points. And you'll see that the technology, the MetalJet technology, is an attempt to do that, and I'll go through some examples of that. And then also the embracing of digitalization to improve business outcomes. As you'll kind of see in the content, is one of the key areas is that we'll focus on is the cycle time to get to a part, and really improving that, and also improving a customer's experience and the products that our customers are providing their customers. So with that input and kind of that direction of focus, let's jump into the content. As Zach mentioned, I'm the Senior Global Product Manager at HP with MetalJet. I've been with HP over almost 6 years now, and prior to that, spent 20 plus years of my career in industrial settings and supplying large steel mills and different customers with industrial solutions. So I'm very well versed in that, and that background brings a lot of good content and experience in solving problems with our customers today. So session one, as Zach mentioned, was a kind of an overview of our end-to-end process, and then just to level set everybody on that. This is kind of an overview of what that workflow and that process involves. As you can see, I provide this to kind of get everybody's mental model of MetalJet and binder jetting in particular, and how it's going to compete and complement traditional manufacturing. But I'm going to pull my pointer up here. I want you to kind of focus on the front end of this, on the digital workflow portion of this. This is where we'll spend some time and emphasizing where the improvements in productivity and capability to bring value to for our customers as compared to traditional manufacturing. Okay. So as I mentioned earlier, manufacturing is constantly evolving, and over the years, as the world changes, new production challenges emerge. Manufacturing has been on the forefront of leading and meeting these challenges. The promise of additive manufacturing and its influence on Industry 4.0 is powerful, and we believe that benefits, but also that it requires more than just intent to move the needle. It takes action and proof points to show that we're moving in that direction. As you can see, this as over time, manufacturing continuously evolves. So currently, we're at a pretty big inflection point as it relates to manufacturing. When HP set out on our metal jet vision and mission a few years ago, we can never have imagined the amount of supply chain and trade disputes and upheaval the world will be faced with today. And I highlight a couple, four of these that we're seeing a lot of impact on. Is, I'll go from in clockwise. Customers are demanding and requiring faster product cycles. The product life cycle curve that we typically would see that would last 10 years, give or take, now is lasting sometimes months, sometimes, a year. So the faster product cycle, so innovation in the product cycle and getting things to market faster is imperative. The digitalization of that process and using digital tools to help innovate and meet that faster need is imperative. So we're embracing that to help our customers become quicker to market. Supply chain complexities with, as I mentioned earlier, trade disputes, supply shortages. Any manufacturer that you talk to will attest to this. Some of the simplest supplies become some of our greatest headaches. And so customers we're noticing are looking at multiple options and ways to either we call it reshoring or bringing in-house the ability to hedge that risk to their business. And then skilled labor shortages, as we're saying, the continuing pressure on the low labor rates and or unemployment rates that is causing skilled labor shortages to be in high demand. So those skilled labor is imperative. So what that means is volatility in the global markets is the new normal, and in order to be successful in that volatility, is that the agility, being an agile company, is imperative. So what's the opportunity we have in front of us? So in a relative scale, additive manufacturing is just now scratching the surface of manufacturing opportunities, as you can see here. Not all products are suited for 3D printing, but several manufacturing consultants have estimated that the addressable opportunities within today's manufacturing industry are well over 40 billion annually. The primary verticals, that we noted on here on the right, appear to have the right combinations of opportunity, need for innovation, and value creation utilizing 3D printing. And I'll touch on a couple of these a little bit later. So faced with the opportunity that we have in front of us, HP is taken that and said, okay, how can we be a player in that market and help expand that market? And so our vision is, vision and missions statements are provided here. Again, we'll focus on a couple things. One is to embrace power of additive to not only bring a healthier, sustainable world, but also to utilize the data-driven solutions that additive or 3D printing provide us and enable for us. So you get better personalization, performance, and design possibilities. So the strategy to do that is, and we don't take this lightly and recognize that, creating value for our partners and our customers is why we're in business. We are in business because our customers see value in what we're providing. It's important to acknowledge that as the world changes, we're facing immense challenges, and so to do that, the strategy is to strengthen current platforms through filtration, as an example, or hydraulics, certain consumer goods, but also to disrupt certain areas to be able to improve performance around, say, heat management designs. Using 3D printing, embracing 3D printing to come up with new designs and options that will allow you to come up with better performance. Fashion is, as I mentioned, is one of those areas where the product life cycle of fashion is probably months. And so enabling the quicker turnaround for fashion is good. And customers are embracing that. And then around tooling, as you see, here's an example of some conformal cooling that traditional manufacturing techniques just cannot enable or do. And this is enabling better tool life, longer tool life, better performance from the tooling. So, focusing on speed and execution is really what our strategy is about, and enabling our customers to do things that they hadn't been able to do before. So why is traditional manufacturing ready for disruption? I'd say it's a couple areas. One is, again, I mentioned earlier, a lot of the traditional manufacturing techniques are relying on skilled labor, and that skilled labor is becoming more expensive to train and to equip, but also becoming scarce. So it's leading to some basically supply shortage or manufacturing shortages. The lead time and the supply chain inventory challenges are really key as well in terms of what we're seeing. When you have a disruption to your supply chain, with what we found out is that leads to product shortages or the inability to make a car just because of a chip. Things of that nature really are impactful that we took for granted before, but now we're really looking at where our supply chain risk is, or our risk exposure is. And then the other area that we're looking at is, and really what we're hearing from our customers, is the ability to improve current designs or consolidate current designs of products to achieve better performance. And that performance could be in the way of longer life, better thermal properties, more sustainable. So looking at ways to enable new designs to enable better performance. And that can be done with 3D printing. So when you look at traditional manufacturing processes, historical segmentation of this is, on an annual production quantity versus part complexity basis. This is kind of the mental model that many what I call long in the tooth manufacturing engineers will have this in mind. This, when they start thinking about what technology can I use to make this part, this is the mental model that they'll come up with. So the new challenge confronting manufacturers is the consolidation of suppliers. Has resulted in really what I call a high mix, low volume gap. And this is particularly impactful to spare parts, support for legacy systems, and discontinued models. And what that results in is that you end up having this is today's new reality. You've got a gap in this area here, where customers that have high mix or high complexity parts but very low annual volume quantities really are seeing a void or a very difficult time finding suppliers to fill this gap. And so this is an area where we've seen a lot of interest, and we're actually, binder jetting 3D printing is a great fit for this area. Okay. So when we're talking about traditional manufacturing processes, we kind of listed these across the top here, and this is a summary of what those are and their average lead times to begin production of a part or a production run. As you can see here, the lead times are really driven a lot by the tooling that's involved for the product or the production process, and then also qualifying the production process. So these lead times are, when you have these long lead times to get a product to market, it's expensive. There's labor invested, there's tooling investment that's required, there's testing that's required. So you have to be very strategic in how you would go about getting a product to market with the traditional manufacturing processes. And then the other element to this is the relative pain points that each of these technologies or processes bring to a customer, that a customer faces when they're using them. you know, I'm not going to go through all these, but I'm gonna point out here on the next slide that a couple in more detail, the MEM market and the machining market. And that one, I was going to say one other thing at the bottom. What we've identified is for Metaljet, the value that we're creating or bringing to customers through the use of our technology. And I've touched on these in some of what I've talked about a minute ago, but I mentioned enabling the high mix, low volume. But I'm also going to talk about some new designs and new sizes or geometries that we're enabling that customers, you know, at this stage really haven't been able to pursue because of the complexities. So when we look at MEM, you know, the targeted value propositions that we go through when we're talking with MEM customers, and I look at this as really not so much as a competing technology, but as a complementary technology for MEM, because MEM parts, you know, the tooling molds are expensive, they're time consuming to make. And generally, when you make a tooling mold for a MEM part, you want to run thousands and thousands of these over and over and over again. And so what I see then, and usually these parts are fairly small. And so since both of these are center-based technologies, when I say center, you basically pull the part out, and it's got a binder incorporated into the part. You put it in a debond and a sintering furnace to basically consolidate the part down and solidify it and get good densities. You know, these both use a similar technology to do that. And so as such, we really view this as a complementary technology to MEM because of the ability to expand the size of the parts that a MEM company can go after, as well as the shorter production runs that really at low to mid volumes are not efficient for these cases. And so, but the other interesting thing here is that it also enables a lot of design freedom to increase the complexity of parts that the MEM companies can go after and pursue with customers, and the new iterative and integrative design complexities that go inside these. And an example of this would be, say, around tooling for mold inserts. When you're doing shots for the plungers, the tooling inserts generate a lot of heat, and so the conformal cooling, as I mentioned earlier, is an example of integrating complex cooling channels into a part to extend tooling life and improve outcomes for that. The customer pain points around machining, as I mentioned earlier, is very labor dependent. I would say that's probably one of the big exposures for machining, is that a good machine shop will require skilled, as I also say, expensive is another adjective for that, or another word for skilled is expensive labor. Multiple processing steps, and very limited in your design in terms of what designs you can go after, but also in terms of a lot of individual parts that have to be consolidated in separate processing steps. So a lot of handling of parts. You know, the 3D printing and particularly Metaljet technology is able to consolidate parts so that you're not handling parts as much, but you also have the capability to integrate all that work into a single production run. So that improves your productivity, you're cost efficient in terms of low to mid volume runs. Again, it's better once you've set a CNC machine up to run, you want it to run over and over again. In this case, low to mid volume runs are much more efficient to go after. And so this would be an example of how this is maybe a way, you know, our Metaljet technology is a way to expand machining, but I would say it helps alleviate a lot of pain point or risk exposure to the machining customers with their processes. So I talked earlier about design cycles, and this is really where improving and embracing the digitalization of that process pays for itself in spades. So here, typically, you're going through a traditional design cycle as you prototype some parts, and you're in this space maybe for a while to try to different part sizes, different tooling molds. You try to do this invest as little as you can in tooling mold since it's expensive. So this is an expensive proposition. You're not the number of designs you can look at. You tend to really narrow that down up front to like a handful. Get into a design freeze, you build your tooling, get into process development, and go into production. The time spent in prototyping to build tooling phase can be long, up to 9 months, depending on what you're looking at and the size of the parts. And with MetalJet, we digitally iterate in this area to evaluate multiple options without that tooling expense. So what ends up happening is you basically go from prototyping to process development and not have to and skip the steps of design freeze and building your tooling. Yeah. And I'll go into a customer example of that here in a minute. And this is an example of where a customer has embraced this, and they were able to go through look at 3,400 different types of parts in 56 different design iterations in this single cycle, and still shorten their time to market. So they were able to go through these different design iterations, different types of combinations of designs, and different parts and elements within these parts to find out which one is provided the best customer feedback, customer solutions, and production ease. And so what ended up happening is the design fluidity that they were able to provide into that. They folded that into an iterative development process with their customers, so they were able to get real-time customer feedback in this process loop, such that they had to go into production and say, "Oh, well, we produced this," and the customer says, "That's not what I was looking for, not what I was really liking," and they have to go back and start this over. They were able to get that real-time feedback from customers during the design and process development process. And this enables rapid customization. So if a customer wants to add a tweak here or there to that design, you're able to do that in this loop, and then still do that in increasing your speed to market. So this was a real life example of a customer where they were able to, again, embrace this and provide a valued offering to their customer in the end. So, in the end, what are the business outcomes that we're hoping to, that we think and that we're hearing that customers are providing us in terms of feedback on the HP MetalJet is we're able to efficiently accelerate innovation. You're cutting down, from days or months or weeks of development time into days. You're able to, weeks and months of work and effort and cost is really narrowed down into days and a much more circular and real-time feedback from customers. Your development is constantly in motion. So, it's in parallel. You're not, when I say parallel versus serial, what that means is that you don't have to lock in a design, your development design, and then everybody goes off and then you go into production. You're able to, it's a constant loop and a constant feedback loop from customers to improve on that development and that design. So we call pencils down later. You're constantly doing that work and trying to improve that design, and development never stops, which improves the product cycle and then performance. And then production. So in production, we're able to launch faster. I'll say on-demand manufacturing. This is a good fit, as I mentioned earlier, for the high mix, low volume type of parts that we're seeing our customers struggle with at this point, as a huge pain point for them in finding suppliers to do this. Able to get to that market quicker. So we see this as transitioning from a concept to production was much faster. And the design modifications were still possible after production began. So these are the business outcomes that we were hoping to achieve, and actually did achieve with several and have been able to achieve with several customers to date. So how do we how did we achieve these wins for the customer? Basically by utilizing the HP MetalJet system and aligning customer success metrics with with the value elements that we provide here. Recognition that manufacturing is not static, but constantly evolving. Constant innovation, identifying, solving customer pain points, which is our primary focus. I mean, again, if we're not solving a problem for the customer, then we're in effect maybe not creating a lot of value for them. So we want to make sure we're creating value for their business. And embracing the digitalization, as I mentioned earlier, to help on the iterative design cycles and development cycles that we show on the front end, to use that space to do the innovation and the iteration on before we're locking in and going into production, so that you get a valued and an aligned outcome for the customer in the end. So thank you for your time today. I know it's quick and it'll hit a lot of information, but I will be glad to answer any questions. And Zach, I'll turn it to you.
Awesome. Thank you, Brett. It looks like we have a few more minutes, so let's go to the Q&A real quick. What is the typical design cycle time for a part?
Yeah, that's a good question. It really varies on the part size and the complexity, but I would say that to a design cycle, what we have is some design guidelines that we've prepared for customers, and utilizing those design guidelines for the technology helps really narrow that down. I would say that a typical part from a design cycle standpoint, you're looking at probably a few weeks till you get to a printable and a tested design that you've been able to get through the system.
Nice. So how do you convince supply chain management to include AM, and in particular metal AM, as a standard option for a sourced part along with the other established manufacturing methods?
Yeah, that's a great question, because in a lot of cases, a manufacturer's, having spent many years in industrial manufacturing and process development side of things, in a lot of cases you spend years setting that process up, and the process to make a part is locked in and set. So in this case, what we try to do is run these parts in parallel to the traditional way they've done things, to show equivalency, capability, and how using our technology is able to replicate and in some cases improve on what they're currently doing in terms of that part. And then that way we can carry that forward into some new designs and new capabilities for that part on how to improve it.
Yeah, that kind of leads to another question. So does HP offer design services to help redesign of parts?
Yes, we do. We do offer professional services options for customers to choose and to use. We do that through it's a combination with our application engineering team, our business development teams. Engaging with them will enable us to engage with you in terms of helping provide a feedback on your designs, what's maybe some improvements on how to print that, layouts and so on. But yes, that is offered through our professional services offering.
Nice, amazing. I appreciate the answers. Looks like we have about a minute left. So before we finish up, I want to hear from you all. Which of these next topics would you like to hear about? We should go to the next slide, Brett. And I'm going to go ahead and start a poll to get your guys' opinion. Give that a few seconds here so everybody can cast their vote. And please keep in mind, in the next few days, we'll be reaching out to you via email. So if any of your questions were not answered live, you'll have the option to connect with our sales team and our application engineers to get those questions answered as well. You'll also have a link to the session 1 of Beyond the Forge. So if you want to go back and review how the MetalJet solution works, like Brett was saying, that'll be available to you as well. All right, I'm going to go ahead and end the poll now. All right. Thank you everyone for attending today's session. And thank you, Brett, once again for speaking about 3D printing versus traditional methods. And we will see everyone next time. Have a great day.
Hey, thank you.
Thanks.